Joseph, you guys are doing the same thing together.
Testing. Testing. All right. Hello, CypherCon. How's it going, guys? Yeah. All right, welcome to track 2. So I'm going to be talking about some cluster cracking and a not so new tool called MDXfind that not very many people know about. So, without further ado, let's have a look at this. Yeah. The next slide. So, who am I? I'm Robert Reif. I am part of CypherCon, which is a hobbyist hash cracking group, and we love to crack passwords. That's what we do, and we rather enjoy doing it. I'm a student currently for systems administration and network security specialty, so that kind of thing. Yeah, I'm all about passwords, you know. So, basically, at the end of the day, though, I'm just a guy with a few graphics cards looking to spend some cycles. And that happens to be on, cracking passwords. So CypherCon is a group of hobbyist password crackers. We compete in all major professional level password cracking. And most people in our group use maybe 1-2 machines at most. So they can manage work relatively easily. However, me, I have 7 terminals and 22 graphics cards in my basement. So it's not the easiest thing in the world to manage all of that manually. So basically, I was looking for any way possible to try and get that easier. And there was an existing tool out there called Hash2Puss. And Hash2Puss was pretty great. Like, the idea behind it was wonderful. And in the beginning, like I said, I was the only person in our group that had kind of an experience with Hash2Puss. Everyone was kind of like, I don't know about that. So I was constantly pushing for members to have a look at how simple it was to handle this kind of work. Like, it was really nice. You could just issue a task and all of your machines go towards one task and they all work collectively together, which is amazing. Oh man, that's awesome. Most of the time, you're trying to pack as many GPUs into one single computer as possible in order to get as much bang out of it. So one day, I get a PM from one of our members, and he says, "Hey, if I program some changes to Hash2Puss, would you be interested in testing it?" And I said, "Yeah. Oh yeah, you bet. I'm going to test the hell out of that." So thus the development for Hash2Puss was underway. So while the original code it worked well. It contained a lot of lines of redundant code, both server and client side. And it was mainly caused by the constant changes of Hashcat. If you have looked at Hashcat in the past 6 months or a year, it has changed dramatically. It is insane how much that's changed. It's gone open source. It's gone to this whole new level. It is an amazing tool, and Adam is amazing for making it. So Hash2Puss basically, it's more refined code, and it allows developers to spend less time tracing through and more time developing. And as developers, just about everyone is like, well, yeah, that's good for me. So Sane, he is our head developer. He's basically developed 99% of Hash2Puss, and a huge thank you goes out to him for all of that. And Blazer is our client developer. He developed the entire client that we're currently using, and I tested it. I tested just about everything you can think of, and then again, we still find stuff that's wrong with it, but it works really, really well right now. Sane is also the creator and owner of hashes.org. Hashes.org is a treasure trove of information. If you crack passwords and this site is completely new to you, shame on you. You should know about this site. The amount of information you can get from here is just insane. So again, a huge thank you, Sane, for putting this up, developing this, making it what it is, because it is absolutely awesome, the stuff you can get from it. So basically, the dictionary you can find on hashes.org, if you run a password audit for your company, and you run the hashes.org dictionary, and it results in 0 cracked hashes, somebody needs one hell of a raise, because that is amazing. And I mean that in all sincerity. This site is crazy. Usually on average, if we get some sort of dump out into the wild, solid 60%, if not higher, just by using the hashes.org dictionary. So if you're not using it, you should be using it. So what does Hash2Pussy have to offer? We have a multi-user environment. We have concurrent workers. We have really quick task dispatch, and our worker flexibility is amazing. So basically here, if we break this down, multi-user, again, each of them has their own permission levels. Some of them read-only, some of them, admins, yada, 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 that kind of same stuff. Concurrent workers, you can have as many workers as possible, and they will all work on the exact same task if you so choose for them to do so, which is awesome. That is a huge problem when you're dealing with Hashcat, is trying to distribute it, and I believe this does it very well. So just as a kind of an example here of usage, as far as worker flexibility goes, Hash2Pussy allows workers to come and go as they please. So you do not have to have dedicated hardware doing this 24/7. It can be hardware that you use for whatever purpose, and then when it's done being used for that purpose, you can use it to crack hashes. So, for example, a common complaint with system admins is that I don't have any dedicated hardware. How do I audit passwords with that? Just for an example now, security-wise, this is terrible. But you could leverage every computer in your office after hours to crack passwords without an issue. Now, again, security-wise, that's horrible. But it kind of gives you an idea of what you could potentially do. And you can use that, even in the cloud if you so wanted to. I wouldn't recommend it. But you could technically put this entirely up in the cloud and have as many workers as possible. And just keep in mind that whatever clients that you have running, those clients will be receiving all of the hashes, all of the cracked hashes, all of your word lists, rules, everything. So just keep that in mind from a security standpoint, that all these clients will have very sensitive data. So let's see here, skipping ahead. Right now, the way it stands, we have a C# client. That is it. Our plans are to expand on this to Java and Python, but right now our C# client works beautifully with Windows, Mac, and Linux. So you can do anything you would like. The only problem with Mac is that Hashcat does not automatically come with the Mac binaries, so you have to build them yourself. That's the only issue there. Otherwise, Windows and Linux works beautifully. So the client and server communication uses JSON, which is pretty great. But it's pretty simple for developers to write clients in their own language of choice, or possibly implement non-Hashcat tools to work with Hash2Pussy if you so choose. So let's have a look here. What's compatible? So Hash2Pussy uses just about every hash type known to man. If Hashcat does it, Hash2Pussy can deal with it. However, the increment mode and mask files are not. And there's kind of it's tough. And the reason why is because as an end user, you see one single command, and you say, I want to increment through all the way from 1 character to 10 characters. You see it as one single command. Hashcat does not run that as one single command. That is a whole bunch of sub-commands. And the reason why Hashcat does that is for basically optimization. That's why it does it. And at the end of the day, it's extremely hard to distribute that because Hashcat doesn't allow you to be like, hey, I only want to run one part of this sub-command, and I only want to run one chunk of it. None of that is supported. So you can run the equivalent tasks in Hash2Pussy that you would do any of these runs as well. You just have to separate them out individual tasks, which really isn't too big of a problem as long as you're not like, hey, I want to run a mask file that has 500,000 entries in it. Like, yeah, that kind of sucks. So we need some terminology before I go any further. The agent is the client that's actually doing the compute work. A task is the command you wish to be completed. The key space is the size of the compute task, but it's not necessarily the actual key space size. And there's a few reasons for that. You'd have to dive into Hashcat in order to fully understand that, but I'm just going to leave it kind of vague for this talk. Chunks is a partial piece of the total command key space. And a zap is a cracked hash that is globally synced across all agents. Pre-configured tasks are saved tasks that can be deployed to many hash lists. Super tasks are a collection of tasks that can be deployed to many hash lists. And super hash lists are a combined collection of 2 or more hash lists. So unfortunately, before we get straight into the web UI here, there's kind of some back-end stuff you have to understand in order to get kind of this full picture of what's really happening here and what is so amazing about it. So we'll have a look at the output from a client machine. And of course, the progress is basically the progress of the current chunk that your client is running. The speed is obviously the performance of your machine. And cracks are how many hashes have been cracked since the last status output. So that number will be updated, basically reset every time you see a new line come up. Accepted are how many hashes the server has received and confirmed since the last status output. Zapped are hashes that other agents have cracked in the cluster and have already cracked in the cluster and will be removed from the uncracked hash list on the local agent. So zaps they keep all the agents updated, which is really, really good, especially if you're doing like salted passwords. The name of the game when you're cracking passwords is reduce the amount of salts. That way you can go a little bit faster. So basically, if one is cracked, it gets synced across all of your agents, and it keeps everything all nice and fast and pretty and going nice the way you want it to. So the queue is how many messages the client is waiting to send to the server. This could be cracks themselves, this could be status updates, and our queue system basically continues, hold on here, let me double check, I'm not sure. Yeah, so one of the biggest problems when we were working with HashTopus is that the SQL server gets overloaded very, very easily. And why they did that was basically because the client had no idea what the server was doing. And let's say the client cracks 10,000, 20,000, 500,000 hashes within the last status update. And the SQL server is like, oh man, we have this huge task to do, right? Well, the next 5 seconds would roll around and the client goes, well, I haven't got another 10,000 more, here you go. And sooner or later, you have a serious bottleneck going and the MySQL server crashes. This resulted in lost cracks, lost work, a whole bunch of stuff, which in our case is just unacceptable. So we made a queue to basically be like, what is the server doing? Is everything okay? And if not okay, let's continue work, but we'll check and make sure that that server is there. If it's there, we'll obviously send it, here's what we're doing, here's what we cracked, yada, yada, yada. Okay, so demo time. This is a live demo, so let's hope that everything works okay here. So pretty much, this is our UI here. And let's say one of the cool things about HashTopus here is that we have Hashcat releases. Basically what that is that automatically updates all of your clients as soon as a new Hashcat release comes out. So basically all you do is you run the binary on the client, and any changes that happen, HashTopus or HashTopus, automatically get updated. So the client binary itself gets updated, and any of the Hashcat releases that come out, you put them on the server, and the client will automatically download, unpack, and you're ready to rock, which is pretty awesome. So speaking of agents here, when you're adding an agent, basically you just have a download link for the .NET binary, and you run that binary. The first thing it's going to ask you for is the URL of your server, of course, and the voucher that you have. So the vouchers are a one-time voucher, and basically it's just a one-time password that you enter in for whatever client is connecting, and then you know that that agent is authenticated, that voucher is only used one single time, and then a brand new one, which is an authentication token, is given to the clients for them to use to authenticate to the server from there on out. And that authentication deals with files, hash lists, everything. So basically nothing is going to happen unless you have a valid token. So you're probably wondering, hey, how do I get some hashes in this, right? Because I know that would be my first question too. So we'll drop some MD5 hashes in here. If we get to that page eventually. of course. Hey, awesome. Okay, so we'll just give this an example name, our hash type, and this dropdown, all of this that's in here is completely editable server side. You can put anything you like in here. That way, whenever Hashcat gets updated, you can just kind of pop new entries in as things arrive. And everything, like I said before, everything is supported. That Hashcat supports binary files, WPA, just about any hash list you can imagine. But for this, we're definitely going to do MD5, because it's nice and fast. So like I said before, the hash list format, you can upload a regular text file. The new WPA format, we do not support the old WPA format because the old WPA format is garbage. So, and of course, binary files should be like TrueCrypt and stuff like that. And we have a bunch of different sources we could do. We can paste from clipboard, we can do from upload, we can do from a import directory on the server, and we can also give it a download URL, and this is basically server-wide. So anything that you would be importing into Hashcat, you'd have these options to work with. But for this case, we'll just stick with the file upload. And then hopefully in a couple seconds we'll have about 4,000 hashes up on Hashcat here. With luck, we'll see. So, boom, there we go. So we have 0 cracked. We have total 4,000 uncracked. So let's make a task, right? We want to crack these hashes. So the command line box here, the command line box basically takes any command you can think of that Hashcat supports and it automatically outputs it to the CLI when it calls Hashcat on the console. So the only things that you'd be entering in here are your task-related stuff. You're not going to be adding a binary. You're not going to be adding agent-specific stuff. You are literally entering the task and the task alone. Your word list, your rule list, etc. So like for here, just for an example, we'll do like an easy brute force. Right? So just going to do all characters there. If you wanted to do a word list, and the word list do get synced across all the agents, of course. We select that and we'll say, we probably want some rules on that just because. And we'll put everyone's favorite best 64, right? Everyone loves that. So now we'll scroll down here. I really wish I brought my mouse. And we see there's a few other things that we could possibly edit here. Usually the defaults are pretty good, except for a few things where obviously it's whatever you preference, your task to be. Chunk size is basically how long you wish to have your agent working on a specific task, or chunk of a task, I should say. And usually we found that 10 minutes is pretty good. You can usually go up from there if you really wanted to, but 10 is pretty good. That way if you lose connection to it or whatever happens, that way it's nice and easy to distribute a new chunk that's not really weird sized and makes things a little bit funny. But you can technically do whatever you like. But the task is small. Task is small. We found another issue with Hashcat was, let's say you have like 1 character, 2 character, 3 character, 4 character, 5 character, etc. It would try to put all of the agents on whatever task was the highest. And you kind of see a problem with this where, okay, everyone's on like 1 character. Well, that's going to take like a couple nanoseconds, right? Like that's nothing. So we kind of set it up to be like, hey, if this task is really small, like we only really want 1 agent on it, right? So then we could be like, oh, well, these are meant for let's say 5 different agents get on 5 different tasks instead of 5 different agents going to 1 single task, and one of them gets has what do I want to say? One of them gets actually given the task, and then the rest of them are like, oh no, now what do we do? So then we go to the next one. It was really, really slow the way they had it set up. But and then we also have CPU-only stuff, too, that's completely separate from GPU, because obviously some algorithms run a hell of a lot better on CPU than they do GPU. So we kind of segregated those off from one another. So you can technically have two different kind of paths going. You can have CPU machines only doing their thing and GPU only doing their thing. But anyways, let's create this task. And as you can say, yay, we have a task created. That's awesome. But it's not going to run because we don't have any priority. The highest task, or the highest priority, gets run first. And there's a few other exceptions to that, but basically rule of thumb is whatever is the highest priority gets ran first. 0 doesn't get ran at all unless you want to manually assign agents to that task. So let's give this a priority of 100. And we should see some agents pop up there in a couple seconds. But that shouldn't be a very quick, should be a very quick task here. So we kind of want to check out the details here. So we'll click on the hash list name. We'll see all the fun run details, yada, yada, yada. And down towards the bottom, we see that we have 3 agents sitting there. And right now, we're figuring out how long the task is. We're benchmarking the agents to see how much compute power that they have. And then we'll calculate out how long is it going to take, or how long of a chunk should we give it in order for that agent to be busy for the next 10 minutes. So obviously that was a pretty short task, so we have all those cracked, and we see a nice big green bar. It means that we have some cracked, and I'm sure that there's going to be a handful more coming in. We see down here on the bottom right that we have about 1,600 or so, and each time I refresh, the agent is trying to upload all of those to the MySQL server, and I'm sure that'll grow a little bit larger. But, so let's get into some nuts and bolts. Like, most of that stuff is already in HashtOpus, so let's get into some stuff that maybe isn't in HashtOpus that is kind of cool. So we can look at pre-configured tasks. A lot of times when you're running hashes, you probably have like a set list of, hey, let's throw this, 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 and this. That's the stuff we always try. That's the stuff that works, right? So there's a way to save tasks on HashtOpus here. If I can find my local mouse. We can see I have a whole bunch sitting here, and they look exactly like tasks, right? I mean, they're pretty much the exact same thing, only the priority is floating. And what I mean by that is, if I issue, ID number 98 up here, and I want to issue that again to another list, that priority of 5,000 is going to be, the very first one is going to be 5,000, and if there's another task already running in the queue, it's going to add whatever's in the queue, plus 5,000. That way, you always have a unique ID, and you can just start blasting out tasks left and right all you want, and everything's all nice and happy. We're not confused at what we should be running. So how do we kind of, make these? Kind of nice, right? So in the new task, just like we were before, instead of selecting a hash list, we could just leave it as a pre-configured task. We could pop whatever we wanted in here, and it would show up as a pre-configured task. And you could issue that out to any hash list, which I'll give you a quick example of real easy how to do that. So we'll select our hash list, and down, if we scroll down a little bit, we see a ton of pre-configured tasks down here. And basically, you just check them all off. That's great. HashtOpus had that, and that's wonderful, and it works okay. But we were kind of thinking a little more quick. We want it batch, right? We want to blast out a bunch of them right off the bat because that's awesome. So we made super tasks, and super tasks basically allow you to group together pre-configured tasks. And you're able to issue these out to any hash list that you have, so you can queue up work really, really fast. And the queue is awesome because you can just kind of move stuff around as you see, willy-nilly, and everything will automatically kind of figure itself out, and whatever's highest will get ran first. But we kind of want to see all the agents running together as one, right? So let's make something a little bit longer here. All right, just a couple seconds. We should have at least one client connected here. And all of them will connect, all of them will get chunks, and all of them will be working collectively on a single task, which is pretty awesome because you really didn't have too many options to do that other than doing it manually, splitting tasks by hand and issuing them through the command line, and it's a gigantic pain. And if you wanted to stop one of them and do something else, you have to issue that chunk to another client, and it's an absolute mess. And let's say you get something else and you want to run something completely different, you have to manage hashcat sessions and a whole bunch of other things, and it becomes a mess really, really fast. So Hashcapacy is able to handle this, pretty well. I think I have most of the basics covered for this. There's a few other like nitty-gritty things that are kind of nice, but I don't have a whole ton of time here, so I want to get into MDXfind a little bit, because MDXfind is a pretty amazing program that not too many people know about. So, MDXfind here. Waffle ended up making this a long time before CypherCon was ever even a consideration. Waffle made and started developing MDXfind. And MDXfind is such a wonderful program, and not too many people know about it. So I really, really want to get this out here, have a few people at least look at it. Basically what Waffle has seen is he's like, some hashes don't follow your standard pattern of like MD5, or SHA-1 and SHA-256, for whatever reason that is. And there's also tools that struggle with extremely large hash lists, talking in the millions. If you were planning on running, a hash list that's, 50 million hashes long, there's not a lot of tools out there that are going to be able to chew through that without crashing, without taking a ton of memory, without a lot of problems happening. And MDXfind addresses these issues quite well. So development for MDXfind started in 2013 after noticing there was after noticing that some solutions for hashes were themselves hashes, which is kind of interesting, and we call that iteration. So MD5 inside of MD5 would be a triple iteration, right? So the original idea for MDXfind was just to simply iterate MD5. I mean, that's where the name comes from, is iterate MD5 this many times. So, but nowadays, there's almost 500 algorithms that MDXfind supports, and that's a huge number for MDXfind, mainly because MDXfind is so fluid with what you can do with it. And as a result, you technically have billions of variations of hashing algorithms that you can use with MDXfind based off the standard, or the 500 that it currently supports. Because you can nest hashes or hash algorithms within hash algorithms, you technically have, any hashing algorithm you can think of inside of another hashing algorithm is a possibility. So MDXfind kind of tackles this, which is, as you can imagine, a huge task. I mean, that's not playing around. So what does MDXfind run on? Just about everything. Windows, Linux, Mac OS, ARM. In fact, some of the stuff that he had coded for the Raspberry Pis and a couple of the other solutions that are out there that are kind of like them were actually better performance per dollar. Performance per dollar, they were amazing for what they were. Awesome. So MDXfind can solve hashes with very long hash lengths. 10,000 characters are supported. That's insane. That's awesome, because there's not too many tools out there that can actually do 10,000 lines in a single hash. MDXfind introduced the hex standard. Anytime that you see a password cracking program out there, that originally came from Waffle. He was the one that first said, hey, we have a problem with really complex passwords when they output, UTF-8 and you name it, and we need a way to output them, and I think this is the way it should be done, and everyone kind of adopted it. So that's pretty cool. Test vectors up to 2 megabytes long are easily created with MDXfind. So here's where MDXfind really starts to shine and really kind of show its capabilities. You could run 1, you could run 2, you could run 100 million hashes with MDXfind, and the performance is basically the same. That's awesome. If you guys have ever tried to run a few million hashes, you realize how huge that is. In particular, for this example here, we're running 78 million hashes, and it only took 3 seconds longer than one single hash. That's awesome. But because of this, we could do some really, really cool stuff with this. So we could do, why not run all of your unsolved hashes all the time? Doesn't matter from a performance standpoint. We can cat everything into MDXfind and say, why run just one list when you can run them all? I mean, it doesn't matter, right? So one of the most common uses for MDXfind is to run multiple hash types at the exact same time. And this is where MDXfind gets really, really cool. So let's say that you just obtained a brand new dictionary and you want to run that one dictionary through all of your hash lists. You can totally do that. So traditionally, you would have to run each list separately, like run the dictionary through your MD5 hashes, then your SHA-1s, then your SHA-2s, etc. So, wouldn't it be really nice to, run that through just once, just one command? MDXfind, you can totally do that, and you probably should do that. And you can run any algorithm at the exact same time. You just feed them in the MDXfind, and MDXfind will automatically hash them out as long as you say, hey, match these or whatever. So again, the flexibility of MDXfind, you can do some really, really cool stuff. So let's take the ideology of running all algorithms in parallel, and let's take that a step further. So you're a pen testing team, and one of your members was able to dump a users table on a company MySQL server, right? So, but the only thing you know about this hash right here is that it's 32 hex. Can anyone tell me what algorithm that is? No, you need more information, right? And usually you would do, okay, let's try MD5, because MD5 is a pretty solid guess. It could be NTLM, could be LM, could be whatever. So we have a list of hashes and no idea what the algorithm is or combination of algorithms are hashed with. So our example dump, again, it's 32 hex. MDXfind can handle figuring out what this is relatively easily by just throwing a few commands out there. And we'll break this down just a little bit in the very next slide here, because I know that's kind of intense. So everyone is kind of used to how Hashcat handles the algorithm use for when you're cracking. Example, you'd specifically state, I want SHA-1, and you'd run that with -M100, right? And because of this ideology of everyone doing that, MDXfind can be kind of difficult to understand at first. And when you look at the output of help, you're kind of like, well, this help is not really helping me, but that's because you have to change your way of thinking when you're dealing with MDXfind. Because MDXfind just doesn't do this one algorithm. You can do that, but you can do any algorithm you wish. And basically what that does is, how you do that is because you can do, you can basically tell MDXfind whatever regex you want when you're dealing with hash lists. So in this example here, we see, okay, we're calling MDXfind. We want to search all algorithms with -H all. We want to exclude anything that's salted, because if you think back to our MySQL table that I showed in my example, I didn't see any salts. Same thing with the user. So basically, MDXfind does salts and users separate from each other. So you can use them kind of interchangeably as salts, because again, you don't know what algorithm that you're using. Does it salt with the username? Is the data that's sitting in there that looks like a salt not a salt, etc. And then we can iterate up to 5 algorithms, or iterate 5 times with whatever algorithm that it's currently working on. So you could just say, if you want to do MD5 nested 100 times, you could just say -H, and then you could go caret MD5 $, and then say -I100, and that would be MD5 iterated 100 times. You could do whatever you like with this. And that is super awesome when you start thinking about stuff of, hey, I don't know what this is, or what kind of really weird algorithm are they using. Chances are, if Hashcat doesn't support it, check out MDXfind. It probably does. You just have to tell it that this is exactly what I want. So basically, I'm kind of running out the clock here, but so I'm pretty much finished. But MDXfind is not going to replace your existing cracking software, but it's one amazingly flexible tool, and you should have it in your toolbox if you're a password cracker. So if you have any questions or any help with any of this stuff, anything that you want to check out, if you need clarification, whatever, send me or China Prime an email, do whatever, get a hold of us, do something, we'll be glad to help you out. We're just a bunch of guys that love cracking passwords. So with that, thank you guys for coming. It's great. It was wonderful. Thank you guys so much.